I think it's already recording.
Oh, okay. Sorry.
That's fine. Okay, so this is our transistor circuit. So we're powering it with 15 volts, and what happens first is the power comes down along the positive rail, and then it feeds into this resistor here, which is a 22 kilo ohm resistor, and then that voltage goes into the C pin of the, it goes into the B pin of the transistor. Then the other values that go into the transistor come from the voltage then going through a potentiometer, which goes into the C pin, and then it all comes out through the E pin at the bottom. So for the measurements of the values, we have the potentiometer set to 2.3 kilo ohms, and we can see that the voltage VC, which is the voltage from the C pin to ground, is 6.03 or 04 volts, and then the voltage across VE is it's fluctuating 4.4 volts. Is now for R2. There are these two resistors in series that give us 19.6 k ohms for the equivalent resistance. So now the potentiometer is set to 2.5 kilo ohms, and then the voltage across pin E is, this is across pin C, is 1.55 volts, and the one across pin E is 1.40 volts. A transistor amplifier. So we have the positive 5 volts coming into pin C of the transistor, and negative 2 volts coming into pin E. The function that we're amplifying is a 0.5 peak-to-peak sine wave coming from the digilant. So we can see here that VC, this is the waveform for VC, that we can see that it's phase shifted by 180 degrees. And also from the network sweep, we can see that initially there's a gain of around 10 decibels, and that there's a gain of 10 decibels, and that the phase shift is also 180.